Hello friends. Today we know that in previous class in quantum mechanics we already studied about to find the normalization constant. So we have to do this problem. Find the normalization constant. Psi is equal to a e raised to ik plus a x minus infinity less than x less than 0, a e raised to ik minus a x 0 less than x less than infinity. So we have to find the normalization constant. For that we know that integral minus infinity to plus infinity psi star psi dx is equal to 1. So there is a function, the function which is minus infinity to 0 is a raised to ik plus a into x, and 0 to infinity the function as a raised to ik minus a into x. So we have to split the limit, that is integral minus infinity to 0 psi star psi dx plus integral 0 to infinity psi star psi dx equal to 1. And we know that integral minus infinity to 0, the psi is like this. Psi is a e raised to ika plus a dx, and psi star in which a e raised to minus ik plus a dx. So in imaginary term a e raised to ik and a e raised to minus ik, that's equal to 1. So the integral minus infinity to plus infinity, minus infinity to 0, that is a e raised to 2ax dx. Similarly we got here, that is a e raised to minus 2ax dx, and we have to integrate, that is we know that the formula integral minus infinity to 0 a e raised to ax dx, that's equal to 1 by a. So here it is 1 by 2a. In terms of, in the place of a we have 2a, so 1 by 2a plus 1 by 2a, that's equal to, here it is a is there, it's equal to 1. So a into 1 by a is equal to 1, and a is equal to, there will be a square because psi star psi now, so a square is there. So a square is equal to a, so a is equal to under root a. So we got the normalization constant for this wave function. And how to find the normalization constant in 3-dimensional. So for 3-dimensional, for 3D we know that integral minus infinity plus infinity psi star psi not dx or dy or dz, we have d tau, that's equal to 1. In Cartesian coordinate system, d tau, that is the volume element, that's equal to dx dy dz, and d tau in spherical coordinate system, that is r square dr sin theta d theta d phi, and in which r is integrate from 0 to infinity, theta is from 0 to pi, and d phi is from 0 to 2 pi integration. And how to express the volume element in cylindrical coordinate system, that is d tau is equal to rho d rho d phi dz. Okay, so in which also we have to integrate 0 to infinity, phi is from 0 to 2 pi, like that. So this is our volume element in 3-dimensional space. So how to find the normalization constant for a hydrogen atom? So this is the question. So we know that how to represent the volume element in 3-dimensional, or 3-dimensional we have to find how to find the normalization constant, we know that. So the hydrogen atom in which they are given that wave function as a e raised to minus r by a naught, and we have to find what do you mean by what is the normalization constant for this wave function. So we know that psi star psi d tau is equal to 1. So psi star psi means mod psi square because it is real. So mod psi square d tau is equal to 1. So this is in terms of r, and also we have to we know that it is a spherical coordinate system. So d tau is equal to r square dr sin theta d theta d phi. Okay, so we have to integrate this expression. So we know that the wave function is a e raised to minus r by a naught. So psi star psi is a square e raised to minus 2r by a naught, and the wave function is r, volume element is r square dr sin theta d theta d phi, and we have to integrate this, that is a square e raised to minus 2r by a naught into r square dr from 0 to infinity sin theta d theta from integrate from 0 to pi d phi from 0 to 2 pi integration. So here a square can be taken outside, and also how to find that e raised to minus 2r by a naught r square dr, and here it is integral sin theta, that is minus cos theta from 0 to pi, and integral d phi is pi, so that is integral 0 to 2 pi d phi, that is 2 pi only. So this is integral 0 to infinity x raised to n e raised to minus ax dx. This is the formula. So this is a gamma function. So a square into the function, if it is x square, that is 2 factorial divided by a raised to, a is 2 by a naught, a raised to n plus 1, that is 2 plus 1, that is 3. So this is the integration for of this function, that is it is a gamma function, that is the general formula, that is integral 0 to infinity e raised to minus ax x raised to n dx, that is n factorial divided by a raised to n plus 1. Okay, so here we get 2 factorial divided by 2 by a naught all power cube, all and cos theta, that is 1 minus 1, that is 2 into 2 pi is there, so that's equal to 1. So a square into 2 divided by 2 cube is 8, and also there is 4 pi, and a naught will be given there. So we get a is equal to 1 by under root pi a naught cube. So we get the wave function psi is equal to a raised to minus r by a naught. Wave function for the hydrogen atom, the normalized wave function for the hydrogen atom, that is 1 by under root pi a naught cube e raised to minus r by a naught is the wave function for a hydrogen atom. Okay, so this is all about the normalization. Next we are going to discuss about the probability. So what do you mean by probability? Okay, so probability, in which we know that in particle may exist anywhere, so we have to set a limit, and we have to say a probability. So we know that from a place x1 to x2, the wave function probability is psi star psi dx. Okay, integration of x1 to x2 psi star psi dx will give you the probability from x1 to x2. This is the basic idea. So if you want to find the probability from a position x1 to x2, you have to integrate from x1 to x2 psi star psi dx. Okay, so we know that the wave function of the one-dimensional box. So one-dimensional box, we know that the wave function, that is psi is equal to under root 2 by L sin n pi x divided by L. So this is the wave function for a wave one-dimensional box For that, v is equal to infinity there, v is equal to infinity there, inside v is equal to 0, and also one dimension box, the wave function for that 0 to L is the length of the one dimension box. So how to find the probability of the ground state? For that, we know that for a ground state n is equal to 1, so psi is equal to under root 2 by L sine pi x divided by L, and we have to find the probability. So for that, probability for x equal to 0 to L by 2, we have to find 0 to L by 2 probability. So we know that 0 to L by 2 integral x1 to x2 psi star psi dx will give you the probability. So 0 to L by 2 psi star psi, that is under root 2 by L into 2 root 2 by 2 by L, that is 2 by L sine and sine square n is 1 for ground state, so pi x divided by L dx will give you the probability. So we know that 2 by L is here, and for the half the interval and full interval, sine square of something will give you the wave function, the integration will give from the half of the interval, that is half into interval, that is L by 2, so that is 1 by 2. So we get the probability is 1 by 2. From logic also we can say that from 0 to L we know that probability is equal to 1, because the probability to find the particle inside the box, that's 1, and if you find the probability from 0 to L by 2, that is half only, because the half of the length of the box. Okay, and next we have to find the probability from x equal to 0 to L by 4. So how to find for the probability of the ground state from 0 to L by 4. So 0 to L by 4 psi star psi, that is 2 by L sine square pi x divided by L dx. So 0 to L by 4. So 2 by L can be taken outside. So 0 to L by 4. We know that sine square x is equal to 1 minus cos 2 theta divided by 2. Okay, so we can take as 1 minus cos 2 pi x divided by L by 2. Okay, 1 minus cos 2 theta divided by 2. 2 can be taken outside. So 1 by L is outside after cancelling 2. So 0 to L by 4. 1 dx is that. So 1 dx is 1 dx minus cos 2 pi x by L cos 2 pi x by L dx. Okay, so we have to find the integration, that is 1 by L integral 0 to L 1 dx, that is x from 0 to L by 4 minus cos 2 pi x by L integration, that is sine 2 pi x divided by L into L by 2 pi from 0 to L by 4, and this is 1 by L into L by 4 minus, that is sine L by 4, L cancel, that is sine pi by 2, that's equal to 1 only, and sine 0 gives 0. So minus L by 2 pi. This is after putting the limits. So this is L cancel. So 1 by 4 minus 1 by 2 pi will give you the probability. 1 by 4 minus 1 by 2 pi will give you the probability from 0 to L by 4. So very simple idea. We only do that sine square x is changes with 1 minus cos 2 theta divided by 2, and after we have to integrate them and put the limits, and we got the probability. Okay. Next we want to find the probability of one dimension box from L by 4 to L by 2. Okay, so how to find the probability of L by 4 to L by 2 for the one dimension box We know that the wave function psi is equal to under root 2 by L sin n pi x divided by L. For the ground state, that is under root 2 by L sin pi x divided by L. And probability from L by 4 to L by 2 psi star psi, that is 2 by L sin square pi x divided by L dx, that's equal to 2 by L can be taken outside, and sin square x can be rewritten as 1 minus cos 2 pi x divided by L divided by 2 dx, and that is 2 can be cancelled, that is 1 by L by 4 to L by 2, 1 dx minus cos 2 pi x divided by L dx. So we have to integrate, that is 1 by L, 1 dx, that is L, from L by 4 to L by 2 minus cos integral, that is sin 2 pi x divided by L into L by 2 pi from L by 4 to L by 2. So this is 1 by L into L by 4, L by 2 minus L by 4, upper limit minus lower limit, that is L by 4 minus, that is when we substitute L by 2, so we get the sin pi is 0 only, so first we get 0, so 0 minus means plus. L by 4, when we substitute L by 4, so L cancel, we get sin pi by 2, so that is we get L by 2 pi. So we got 1 by 4 plus 1 by 2 pi as the answer for this question, that is the probability from L by 4 to L by 2, that is 1 by 4 plus 1 by 2 pi. So we have a trick to remember this probabilities. If you consider a one-dimensional box from like this 0 to L, this we know that, and also when we take half, that is L by 2, and another half is L by 4, here it is 3L by 4. So if you find the probability, you have to remember like this, the wave function is like this, and the probability is here is less, no, so this is 1 by 4 minus 1 by 2 pi from 0 to L by 4. L by 4 to L by 2, this is greater, so 1 by 4 plus 1 by 2 pi, the probability. And L by 2 to 3L by 4 greater, that is 1 by 4 plus 1 by 2 pi, and 3L by 4 to L is small, so 1 by 4 minus 1 by 2 pi. So you have to remember the value, and you have to find also understand the wave. So for this, the wave probability is less, so 1 by 4 minus 1 by 2 pi, here it is 1 by 4 plus 1 by 2 pi, here 1 by 4 plus 1 by 2 pi, 1 by 4 minus 1 by 2 pi. So how to integrate from L by 4 to 3L by 4? So we know that this is L by 4 to L by 2 plus L by 2 to 3L by 4. So L by 4 to L by 2, that is 1 by 4 plus 1 by 2 pi, plus L by 2 to 3L by 4, that is also 1 by 4 plus 1 by 2 pi. So 1 by 4, 1 by 4, 1 by 2, 1 by 2 pi plus 1 by 2 pi, 2 by 2 pi, that is 1 by pi. So we also got the probability from any limits to any estimated limits. Okay, so you have to remember the values. Okay, and also you have to remember the wave of the one dimensional box from minus L by 2 to L by 2. Here also, when we consider minus L by 2 to L by 2, the wave function is under root 2 by cos n pi x divided by L. Okay, so when we got the probability like here, we got like this, and his is minus L by 2, so half is 0, this is minus L by 4, this is L by 4, and here also the wave function is like this, and the probability is here it is less, So 1 by 4 minus 1 by 2 pi. Here it is greater. So 1 by 4 plus 1 by 2 pi. Here it is greater the wave function. So 1 by 4 plus 1 by 2 pi. Here it is small. So 1 by 4 minus 1 by 2 pi. So how to find the probability in one dimension box? So you have the idea to find the probability. Okay.